I'm Mike Beevers. I'm the Operations Director for Seven Partnership. Been with Seven Partnership for about 13 years now, but started surveying in 2008, which we're discussing before. Survey technology has moved on vast amounts in that time, which we'll take you through today. And this is Rich.
Yeah, my name's Rich Day. I work with Mike at Seven Partnership. I'm their principal geospatial analyst for them. Used to do a lot of site work, but have recently moved more onto the office side of bits and pieces. First worked for Seven back in 2013. So yeah, been there about 13 years as well.
So Seven Partnership's been operating for just over 40 years now, established in 1983. We've started off as a very small company, 2 people. It's grown larger and larger over the years. We first got into rail in the late 90s, and since then that has been our main focus. Obviously, there's been a bit of a drop off, as everyone's probably aware, with CP7, CP8, but that's now starting to ramp back up again. So all the survey we do, no matter what sector we work in, has always been derived from the rail background due to the accuracies that are required within rail. And our vision there to be the geospatial professionals of choice. So if we jump straight into it with rail and guided transport. So as mentioned, one of the leading UK rail specialists in survey. We deliver over 500,000 yards of mileage a year to various different companies. We work direct for Network Rail with the high output renewals. So that's taking place all over the country. We do large projects, for example, Trans-Pennine route upgrade and the Core Valley lines, which is a bit close to home here. And we're always looking for latest technology and trying to keep up to date and advancing, and also doing a lot of approvals as well for new equipment. So we get a lot of invites for that side of things as well. So if we move to the next one. So talking about technology and innovation. So we try and look at equipment that already exists and look at problems that exist out there. So this bit of equipment here is called the Stream Up. So what it is, it's a ground penetrating radar, traditionally used on the back of a vehicle to be driven at road speeds to gain an understanding of the underground world. So that includes voids, any services, hidden assets, and things like that. So you can see here we mount it on the end of an RRV arm. And what this does is it uses radar, uses visibility underground, and changes the density, looks for differences in density underground. So if there's a big void, different wet beds, that side of things. I can move on to the next slide. It's fine. So you can see it there at the top right-hand side there. So that's mounted on basically a tow bar. And what we can do is we can run that up and down, assess the 4 foot, the 6 foot. And what that does is identifies a number of different things. So you can see the depth of ballast. So we've been asked to look for the depth down to the bridge deck in certain areas, which mentioned there, services. So any services, UTXs, that sort of thing. The main focus that we've been using this on recently, which we've been in partnership with Quattro, is down on the Core Valley lines here, which was for hidden assets up and down the line. So there's a lot of culverts at the moment that are on paperwork, on plans, but there's absolutely no visibility. So they've done a walkout. There's absolutely no sign of it. So what we're doing is going up and down, looking for these hidden assets, essentially big voids, because what they're looking to do is increase the speed of the line. And obviously, if there's a big void under the underground, there's going to be a big issue if they could start increasing the speed of the line. So you can see there, we can pass up and down. On the system itself, it's positioned with GPS, so plus or minus 20 mil accuracy, but also built within there is an APS, natural position system. So as there's movement going around, it smooths out those tracks. So if we go underneath a bridge, for example, or heavily vegetated where the GPS signal is not too good, that APS will carry that position through until we regain the position of the with the satellites. But you can see there at the bottom left, you can see going underneath the bridge. So what we've been given is an area roughly where that is in miles and chains. We've then been given an extra 10 chain either side to travel up and down. But what we're starting to do now is they've seen how fast this is. We can drive, obviously, when we're in the possession with the RRV, plus or minus 4 or 5 miles an hour. But we can just carry on driving that. So as we're transiting to these sites, we're collecting data anyway, because why not while we're driving there anyway. You can see the sort of detail you get at the bottom there. I mean, the black and white image there, people absolutely love looking at that data. I'm not going to bore you too much into looking into that, but that is showing the hyperbola there, that sort of curved mount. So that is a service. So that's so. And then what we do is we give a report and then give a 3D drawing of where these are from a depth from the surface down to the actual more the soffit of the actual culverts that we found. So traditionally that would have been done with a hand push cart with one antenna, and then you can only get that data in one direction. But that system up there's got 64 antennas in it in both X and Y positions. So you're collecting data in both directions as you're driving along, basically. And then you're collecting about 1.58 meters, 158 centimeters width of data as well as you're pushing it along. So again, a lot better than pushing it down the CES. I mean, and a lot of pushing GPRs down ballast, and it's not very fun at all. It gets trapped, you're bouncing all over the place. So this is air mounted as well, so it doesn't actually need to be touching the ground for it to work. It hovers above the ballast, so you're getting that nice seamless batch of data. It's about time.
Dodgy connection.
There we go. So yeah, the ultimate aim for this piece of work was to find hidden assets. But as a side, we are looking at wet beds. We're looking at different services as well across underneath that might not necessarily be on any statutory undertaker plans. And even if they are on statutory undertaker plans, they're normally good to within up to 10 meters. Sometimes we found gas mains which are not where they're supposed to be. So what happens after this is like we were talking before about asset management, and they'll go out with a GPS post. We'll give them a coordinate. They'll go and set this out and put culvert markers on the sleepers so they know where these are for future use. So that's the next stage.
So you recorded speeds, but walking pace, would you say?
Yeah. So to be honest, that bit of kit can be used up to 70 miles an hour. So you can collect data a lot quicker, but due to working within possessions, you have to be at 5 miles an hour at maximum speed. Does anyone want any more information on that before we move on?
No, it's just interesting in that we using GPR now. We record it from a train as well.
Yes.
We're looking for some of these things. That's more focused on the
ballast.
Yeah.
Yes, that's the SRS system, isn't it? So IDS created both systems, to be honest. So this system's created by the same people who make it both. And this system here, we've created this in partnership with Quattro on behalf of CVL. So that is the only system in the country who do this, to be honest. So that whole frame around the outside there, we've created that with Quattro, very kindly by Amy, like funding it and helping us along the way, all the way through. But yeah, you can see there we've created little skid plates at the bottom, a little halo around it, because we all know on track there's posts and all sorts sticking out, and that kit is very, very good, but the housing, as with most survey kit, is not very good. It's just thin plastic, so if it's to hit a post, it would crunch. So yeah, we've had to create a bit of a fail safe for ourselves there. But yeah, it works very well, and yeah, we're finding quite a lot. This also leads into a report. I did a presentation on this for Trans-Pennine route upgrade a few years ago, because there was a report that Network Rail did up on the Scottish borders, the borderlines, where there was an argument between using trial poles against GPR for installing new OLE stanchions. And I can't remember the exact figure, I can get the report up, but we were finding like 96, 98% of the time GPR was finding what the trial poles were finding anyway. But we were able to collect kilometers of data a night compared to doing a couple of trial poles a night. So it's that sort of thing with speed against risk and bootstop ballast as well, that sort of thing, being able to keep people away from track as much as possible, because we're in the back of the RRV, admittedly in a cage. It'd be nice in the welfare unit with nice and warm, but we're out in the elements, obviously down in South Wales in a cage, but we're obviously off track still, safe out of the way.
Yeah. There's been trials on like tunnels and machine stuff that people did.
Yeah, so there is a different system for that. It looks very similar, but like you said, it's more for tunnel conditions. It's called the Stream T. Which stream?
Finding voids and stuff.
That's it, yeah. So it can find. So we have done it in the past on Huddersfield Tunnel, because there was leakages coming through the tunnel and they want to know what the condition was behind there without having to excavate it. So yeah, there was voiding behind, like you mentioned, voiding and things like that. And especially when they're looking to install OLE arms, it's a very powerful thing to be able to know, right, we can't really drill into that area there, we can move along, that sort of thing. So there is a different system for that. We can't do it without them just because it's on the tow bar. So if we did, it wouldn't stay up. But very similar system. It's just that that one's more usable for rotating around.
Could you use like a sticky question, like a large drone or something? Could you effectively run it at the?
Yes, so that is, in the past year, that has become more of a reality now with drones. The problem is the closer to the ground you get, the better results you do get. With drones, they are used now at the moment, and it works very well for something like if you're following one massive gas pipeline across fields and things, perfect. That's great for drones. But when you're looking for something in particular, especially like a culvert on track, we're not quite at that stage yet. There's no reasoning as to why it wouldn't be something at some stage, but as we stand now, it's not really suitable for that sort of thing.
A question online, if I can. Yeah. Do you also measure ballast fouling? If yes, what are the GPR requirements for ballast fouling measurement?
Yeah, so this system doesn't do it, ballast fouling, but the SRS system, which was mentioned earlier, is perfect for that. So the other system that mounts on the front of a train on an RRV, you drive along, it's got 3 antennas, one sort of in the 6 foot, one in the 4 foot, and that will drive along, and it almost gives you a graph and gives you a red, amber, green sort of rating on the ballast as well, and gives you all sorts of details if there's wet beds, ballast fouling, that sort of stuff. And but what this can do compared to that system is we've had it with high output. We were discussing it with them because there's a membrane that you put down underneath the ballast, and when they're slewing tracks and things, that can get snagged every so often if they don't know the position. So this has been used for that as well, knowing where that difference between the membrane to the ballast to the actual ground underneath as well.
One of the main reasons for that development that Mike was just talking about is the amount of limited time that we're actually getting on track now. The amount of time we get in possessions is becoming so short. In some areas, we get as little as half an hour, maybe, other areas, particularly, we've had a lot of sites around Bedford recently, where you're lucky to even get an hour and a half, 2 hours on some of the lines there. So there's a real push to collect as much data as we can in that time. From a client kind of side of things as well, we're also hearing a lot of talk about a minimum viable product, about cost cutting, what's the minimum amount of information they need to be able to get the job done. The whole kind of survey once used many times approach of Chris Preston is maybe kind of slowly going by the wayside, possibly. But this has led to other interesting developments and where we're pushing now to with some of the Amberg track trolley systems that we're using, because it means that decision between how much data do we need and how much time we've got available is not quite as uneven as it potentially was even just a few years ago. We've got a couple of systems developed by Amberg Technologies. One is the IMS 5000 and the other is the IMS 3000. It's essentially the same kind of trolley system, but they're just set up in different modes. I'm sure probably some of you may be familiar with these, but depending on what is required, we can actually run these with GPS receivers as well. So depending on the level of absolute accuracy required, you can actually get away without any ground control, depending on what you're using it for. But it does allow us to collect an enormous amount of data in a very limited amount of time. We can get, particularly with the 5000 system, which has the profile scanner on it, we can get full 3D point clouds of the rail corridor, the visible rail corridor from track. We get all the track geometry, absolute relative positions. We get all the gauging measurements, height and stagger positions, platform gauge and stepping distances for platform edges. All that can come out of one single push, and we can do that at walking speed. To get a dense data set, you're talking about a meter a second. So once all the controls in place, with this system, to achieve like the band 1 type accuracy, we do need control to do it. But we can collect enormous amounts of data all in one go, and then we can do all the extraction in the office afterwards, minimizing, making the most of the limited time that we get there on track. The 3000 system is slightly different. That is more just about kind of clearance relative type setups. So it's all about data and plates, but we can actually get the track geometry from that as well by just measuring the horizontal and vertical offsets. A slightly a modern take on some of the older techniques, maybe.
Sure.
It's probably the easiest way to think about it. But as I say, we touched on it briefly there. It's all this 5000 system is approved for platform gauging and heightened stagger extraction now, so we can get all that through automated extraction routines. That is one thing that it does work really well on cable positions. So because we've got the accurate track center lines and the railhead positions, we can extract the railheads and bit of trigonometry, and you can calculate the height and staggers. We can do the same for the platform gauging as well. There's automated extraction tools now for platform edge, so we can do the clearance, and they've recently brought in stepping distance calculations following several discussions with the gauging team at Network Rail about what it was they actually wanted. So that's in the process of being automated now as well.
Been a long time coming.
So the day they move from SEO files into slightly newer techniques for clearancing, I think would be a big step as well.
Yeah, we had many discussions with James Sweeney. I don't know if you've heard the name, with James Sweeney over the years about looking at using point clouds rather than using SE0 files, because you've got the point cloud, you've almost got a 3D image there of what's going on the track. You could almost put a model of the train on, which we have done just to prove you can do it, and drive it down track. And then you've almost, instead of you having 1,000 SEO files that you got to rummage through and check and clear route to and things like that, you could just drive this train down, and in about 2 seconds you can have 10 kilometers showing you where there's any fouling or anything like that. So that should be the way forward, to be honest. But I know
passing through that like kinematic envelope through the point cloud, it's doable. It's just a change in workflows and methodologies. Particularly with the 3000 system as well, we can load up design information, and we're doing it quite a lot with the tamping units at the moment, aren't we? So we can load up the so we can give you immediate results, calculating slews and offsets and bits and pieces, all to that design information. And then I think how many tamping sites we've been working with recently?
6 we've done, and we've got another few coming up. So we do pre and post. So we go in before, give it the position of the track now, obviously measuring data plates and things like that. And then we follow behind very closely the tamper afterwards as well, just to prove that it's in a position as designed. And we also feed that, so the export on site as well is from the laptop straight into the tamping machine as well, so if there's any areas where I need to move it as well. So it's quite a seamless workflow when you're on site, so minimal office time needed, but it's on site.
Using that methodology, weren't they?
They're not at the moment, believe it or not, with the trolleys, but we do the pre stuff. So we go in and survey it before we give them the as it is now, and then they do their design from there. They don't really do the post one from our end.
I mean, these workflows are great. You do need to be careful with them as well. The IMS stands for it's a bit like the APS system that Mike was talking about. It's the inertial measurement unit. So it's got accelerometers which help it generate the trace, and we can control where that trace goes by tying it down to control. But the placement of that control is key. Otherwise, the trace can just wander and drift. And depending on what the track is doing, knowledge of roughly what you're expecting before you go to site is really helpful, because as soon as you start getting on tighter radius curves, you need more control to control the trace. it's more stable in height than it is as planned. So you got to get the spacing right, and it's got to be implemented in the right way to get good deliverables out of it. And with so much information hanging off the back of it, it is really important that that workflow and understanding how that kit works is key. And that's where we've been quite fortunate to have access to various test sites that we can use, where we can go and test it against all the different surveys. Like, I think Mike will probably touch on it in a little bit. But we've done all those comparisons. We know the workflows. We know how much control we need to get reliable results out of it every time.
Another question online: is it possible to detect sleeper cracks? If yes, what is the minimum crack width measured by this device?
Well, that's a good question.
Could you detect a sleeper crack with a point cloud?
You could, but
It's pretty data. It's pretty dense data, isn't it?
it is.
But whether you'd see a crack if there was a change in level in the sleeper, as a result, I think you'd probably pick that out. But I mean,
Not yet available.
no,
I mean, the next stage now with these trolleys is they're starting to integrate imagery with it. I know a lot of the work's at night, so you will have to have floodlights and all sorts of lighting around it, but the new profilers are starting to come out with imagery now as well, photographs. So it may be that you could overlay the imagery with the point cloud and detect it that way. But yeah, in terms of cracks, I mean, you can run these at 100 or 200 hertz, can't you? So you are looking at close to 1 million points a second as it's in a profile. So like Rich said, if there was a step in data, you could definitely see it. If it was a hairline crack, you're probably not going to see that.
But I think, as they move on, I mean, at the moment, the imagery to link to the trolleys is essentially like, for want of a better description, like a homemade solution. But they are looking at addressing all that. So it won't be long before they have their own inbuilt systems with lighting rigs, and a bit like our mobile mapping unit that we use on the highways has a pavement cam. So that is literally focused at the road surface, so you can make assessments of the road condition. So that isn't that far away. With sufficient lighting and a really focused camera, it wouldn't be unfeasible to go, particularly more with like recognizing features in imagery now and a bit of kind of extraction that way, and like the AI that's coming in with like training computer models.
We do a lot of work with One Move Circle on using digital because machine learning has just come such a long way.
That's it, yeah.
And it's remarkably quick how it'll learn to pick out certain features for you. Yeah, so
that's it. I mean, we did a lot of work with Cordell. I don't know if you've heard of Cordell. So we did a lot of helping them get approved on Network Rail down on HS1 a few years ago now, wasn't it? A few years,
22-ish maybe.
About that, yeah. So, but their systems, like you said, they're machine learning, and they can drive their system on obviously on freight trains and things like that. But they're able to use AI and learning to detect areas of vegetation that requires work on it, areas of graffiti that might need clearing up and things like that. So it's already doing that automatically and giving them GIS-based sort of map view here, and you can click on it and get that information. So that's definitely the next side. The way it's all going, to be honest.
I'm assuming we had detection by the wheels rather than the scanner.
Yeah, that's right.
So there was a similar discussion with Trimble not long back. And because we don't currently have a way of automating those cyber readings.
No.
And I was just wondering, is there a possibility we get cyber? I know you've got like a lot of dense points of that point just scaring the noise and reflection, isn't it? But
that's it. So
is there a possibility?
With the railhead itself, that's from the actual trolley, that's not from the scan data. So that's what it has is like a gauge bar. So when you put it on the track, it's got these little ceramic wheels. You pull over a bar and it pushes itself against. So as the gauge changes, it can tell where that changes. So it uses the center line and almost gives it a distance to either side, so it can generate those track lines.
The trolley's generating a track center line, and it measures can engage to then automatically.
Do you want to get scanned off the rig, or
so you get, I don't know if you can possibly just about see it on here, There's a 2-side and a 1-wheel side. You get all the railhead on the 1-wheel side, but on the 2-wheel side, you get its minimum amounts just because of the geometry of the frame.
Any options to offset the sort of scanner in front of the trolley or anything? Or?
It's something. It's something that they've kind of investigated and looking at. I mean, they could definitely change the design of the trolleys, no doubt, but it's whether they believe they could get it out reliably enough to meet that market demand as to whether they would do it or not.
But if we have that option, that solution, it would be a no-brainer for us really to sort of say, yeah, we'll go there.
Yeah, I mean, the way we have done it in the past is because of how quick the data is anyway. If you've got a kilometre section, because if you're getting on a one access anyway, you push down, flip it around, and push it back anyway, and those two data sets will be combined. And if you're pushing on the other track anyway, you'll get a lot of that data from the other track again for the running edge. So if say you've got that 2-part wheel on the CES rail on both sides, so you're scanning the 6-foot rail. When you're pushing on the opposite line, you will then scan that railhead. And that if you're using the same control, everything should be relative to everything anyway. So those two data sets should combine spot on almost with the data sets. And the way we do it is coordinate this using obviously back to traditional ground markers, PGMs with post-screen markers, traverse level or traditional with the odd total stations. Going to say the odd light ones, total station things. So that's just to get back to the band 1, and then all we do is put a black and white target on a pole with a bipod as we push it through. So that part of it is if we push down one track and push down the other track, we can get the railheads on both tracks from just the push up and down, doing it that way.
Did you say that using the amber trolley, you can get front offsets like lifts and slews for the tamper rather than having to put it into software, like design or calculating it yourself?
Yes. So when you with the 3000 system, you go along and you can you ping your measurements and control points, and it'll do instant comparisons to designs. So you know how much
shows there on the right hand side actually is the red areas.
So that's not. Oh, I thought that might have been. What software is that? Is that like the software format?
That's Amber Grail.
Amber. Okay. All right. So that.
But that
right.
I think Mike mentioned it earlier. Maybe I think that information can be fed from the trolley directly into the tamping machine.
Yeah.
Oh, nice.
And then you obviously, yeah, like you mentioned, as we're pushing it, you can see it real time as well as you're going through it. But normally we don't give the results real time. You can see them real time, but what we'll do is we'll push on site, finish at control point, and then sort of process it on the laptop there and then review the data, which we can do on site.
Cheers. Thanks very much.
Any more questions on the chat or anything?
No.
Oh yeah, come on.
What about its use of your services in devising detailed track layouts for tramways in busy streets?
Yep.
Like A38 Gloucester Road in Bristol or Newport Road here and Cambridge Road here in Cardiff.
Yeah, I mean, we've done it in Birmingham on the tramways there. We've pushed it along. The gauge sometimes can differ on tramways, but there are attachments which we can widen it or make it smaller. Just the same, apart from you just need traffic management instead of a possession, so we can push down there and get all the relative detail again, as long as the survey control in the first place again.
The trouble is that service records, the utilities own records, are notoriously inaccurate.
Yeah, yeah, they are.
So something like your services to try and plot out where everything is.
The services underground, you mean?
Yeah.
Sorry.
Yes.
Yes, yeah, definitely. I mean,
how can we lay a tramway down with a minimum of disruption?
Perfect example of that is I don't know if we go. I don't think we go through it a bit later on, but Coventry are putting a very light railway in at the moment, and we've worked extensively on that project. So the mobile GPR system we showed there. And the mobile mapping system, which we'll go through in a bit, we did 7 kilometres through the city centre. We lifted every cover, traced everything, used the GPR, but we also 3D modelled everything, all the chambers, all the underground, as well as above ground. And what that allowed us to do was show any class, basically clash detection. So when they put their design in, it flagged up clash detection with the gas main. So instead of paying 150,000 to move a chamber or a gas main, they could just tweak the design slightly, which they can do in the office straight away to move that design over, and that avoids any costs when they start the building straight away. So I think I might have a video of it in a bit to show sort of an example of that data set, but that's a perfect example of it. And yeah, one of our BIM managers is seconded to Coventry Council just to look after all that database as well, for that reason. So yeah, it's a perfect example. I mean, being able to drive with the system, scan the roads and below ground all in one night for 7 kilometers and then process it gives a good high level plan straight away there, before we start the more intrusive surveys, I suppose.
And I think that kind of above and below ground view in 3D models, point clouds, etc., has been there on the highways for probably a few years now, hasn't it? But on track side, I think I don't think anyone's doing it below ground to the level of detail we're trying to do it at the moment, are they? So we're trying to take that same methodology because there seems to be a lot of interest from the people like Amy and people like that. We're trying to develop that whole above below ground type 3D model that people can use.
It's how far down the road surface can you get data from?
So GPR, the ground penetrating radar, is limited. It's not a
Depends.
We get it does, yeah. We get a lot of people thinking it's a glass bottom boat where you can see everything. It's fine with that GPR. That's not the case. I'm not ever going to say that is going to see everything. So on a good day where it's dry, you're looking around, you're probably looking 2.5 meters with GPR alone. If it's a bad day or the ground's for the clay, that dissipates the signal quite a lot. And you can sometimes get as little as 1 meter to 1/2 meter, depending on ground conditions. It can vary quite considerably. So there's always a bit of a desktop study to know what the area is doing, what the ground makeup is. On the back of that, though, the more intrusive surveys of lifting the covers and actually tracing services and things, you can get down to about 15 meters. So we've traced sewers in London that are about 15 meters down, using a supersonic electrical, sort of gas lines and things like that. Obviously, the deeper it goes, the less accurate, but there's the PAS 128 standard for that shows you the accuracy as they get deeper and percentage wise and things like that. So there is a standard for that to abide by.
Density, essentially.
Density, yes. So that's what GPR works on.
GPR is looking for changes in density. That's what it's mapping. So if you've got a very homogeneous material, then you don't see huge amounts.
Yeah, if you've got a clay pipe in clay, you're not going to see the pipe, but you may see the air gap in the pipe itself. But if you've got metal in sand, you're going to see that bright as day every time. So when we're looking for culverts and CVL, for example, and you've got 2 meter void, essentially what a culvert is, a 2 meter, 1.5 meter void, that is going to show up bright as day just because of the size of it, to be honest. So a little example of just sort of what we can do with this sort of technology before we move on to more of it is a project we ran in Skelmersdale. We've obviously mentioned about all the survey control, which we need to do traditionally. That's the basis of all surveys, like Rich said. If that's not right, the whole survey is not right. So once we got the control in, we managed to survey sort of 12 miles of rail, 10 miles of road, all in one Sunday blockade with all this kit. So you can see how rapid this data collection is. We had the Pegasus 2 Ultimate, which is, if we go on to the next slide. On that, the third image across, you can see it on the back there. So we were able to scan all the roads while the possession was, while the blockade was coming into fruition, and then scan all the rail as well. So obviously that isn't for track accuracy. That was more because there's quite a few embankments and things. So that was more for the imagery and everything like that. But what we did on Skelmersdale while we were there, just because of the good possessions, good blockades, we used a number of different equipment to prove what point cloud data, what this different systems can do in terms of platform gauging, the track alignment, and also clearance gauging. So you can see up there for platform gauging, we used as the baseline the BANS platform gauge, obviously the old traditional, we've all seen that handwriting. What we did then was use the IMS 5000, the Pegasus 2, and Fugro's relay system, which unfortunately is no longer in existence. as a bit of a benchmark, and we did a whole report on it down at the bottom. Same with the track alignment. We used the Amberg GRP 1000, which is a total station track trolley. So that's the most accurate system we had between the 5000 Pegasus 2 and the clearance gauging, which is the 5000 against Pegasus 2 in the relay system. And what we found, especially with the platform gauging, is Network Rail wants to see the platform gauge as the number one. That is the go-to. That is the holy grail of platform gauging, which was fine. We did it against there. But unfortunately, what we did find was all the other systems didn't match it quite as well, but all the other systems matched each other very well. So what we're saying is, if you're at 2 o'clock in the morning with a platform gauge writing in rain on a piece of paper compared to point cloud, which is all in the office, spot on to millimeter perfect, we do believe that the point cloud data is by far a lot better, which they all match within a couple of millimeters, but against the platform gauge, we're probably 5-6 mil difference. So
with platform, traditional platform gauge,
yeah,
it's very dependent on where the operator puts it.
100%. I mean, we've all used one where you're kicking it up against the railhead, and yeah, so there's all sorts of variables. Whereas when you're using a point cloud and you're pushing it through, especially with the IMS 5000, you're pushing it through a platform, everything is relative to that track from the profiler. You're able to measure that to as accurate as what the point spacing is, to be honest. So if you've got a millimeter point spacing, you can measure that right down to that millimeter, as the relative comparison to the track to the platform edge is going to be spot on. But unfortunately, because we had to use the advanced platform gauge as the basis for it, it did show that everything was off. But when you look at the results altogether, just move the platform gauge aside, everything matched perfectly. So it was one of those discussions we had to have with NetworkRail at the time to just show that. So I just thought we'd put that in there, just to show that, especially when we're buying all this kit. I mean, that system on the left, the Amberg trolley, probably about £250,000. The Pegasus on the back there is about £550,000. So if we're buying these bits of kit, we want to make sure it's definitely right, and we'll test it to within an inch of its life before we commit to this sort of stuff. And we do a lot of.
You can buy a lot of platform gauges.
You don't have to buy a hell of platform gauges to last you that long. If you're doing that, you can get a new one every day and just chuck one away if it's for that cost. But yeah, there's definitely pros and cons. But like you said, with the platform gauge, I mean, we still use the platform gauge now, and it's definitely got its purpose. But what we're trying to just put across there is, with point cloud data, that is definitely the way forward to be moving towards in the future. And if anyone wants to, we have done a report on that. So if anyone's interested, just let me know, and so they can bit of nice bedtime reading if you want it. Yeah.
Interesting to know that the platform gauges were calibrated before they were taken out to be used to measure.
It definitely works. It was ours. So we everything was in the report, so don't worry. Everything was calibrated. Everything was up to date with that one. Cool.
Yeah, I think that certainly we've had success with platform gauging using Ryler and things, haven't we?
Yeah, we've got Ryler. For Ryler, we've had all the way back in 390.
Yes, yeah.
And we've done the orders they should have had, really, but
That's right. Yeah, I mean, we were in partnership with Fugro for the high output renewals. We worked very closely with them, and when, to be honest, the news came to us, we were quite shocked it was happening, to be honest. But yeah, unfortunately, that is the way it's gone. Unfortunately,
the Cordell system is just not the same. The scale is too high, so you're not getting the
exactly that. I mean, when we did the approval, I mean, you did most of the report for Rich, didn't you?
Yeah,
to be honest,
Cordell stuff we did, yeah.
And we couldn't.
I think they got band 3 in the end, I think.
That's it. Yeah, we couldn't. Like we were an independent, we were doing a report on it, and like exactly like what you said there. At least Reeler had on the track heads, yeah, on the scanners for the track heads, whereas Cordell was just sitting on the back, and the precision of the rail head just wasn't there for it. Yeah, exactly. Relative measurements to it. Yeah, that's it. We didn't recommend it. We gave the report, and then it was NetworkRail who did it from there. Especially when we're looking at like the trolley system there, I'm pretty sure that's 14 mil on the gauging database. So yeah, it's a discussion for another time. Yeah. I mean, if there's any email address or anything, I can give me email address over, and then anyone that wants, we can share out. It's in the public domain with Network Rail now, so more than happy to share.
I imagine the Cordell one is as well. I imagine.
Probably is. Yeah, I'm not 100% sure on that one.
No,
but
that is
on that. But shut up now. So I just thought we'd go a little bit over highways and bridges. It's not necessarily on track, but it's a lot of assets within Network Rail through over bridges and things like that. So, like we mentioned, we're still very much on the focus of limited time, boots off the ground, trying to collect the data, large data sets, and bring it into the office into a safer environment, and sort of less work out there. But again, even with highways, the first thing you've got to think about is ground control, but not as much as track. If we go to the next slide. So the mobile mapping system, which we saw there. The mobile mapping system we showed before. So this is sort of data you can collect. So it collects color's not as good on there, but it collects 360 imagery as you drive along. So you do get a point cloud and the 360 images, which you can combine and get this nice looking data set. We can use this on track as well, which we did at Skelmersdale, for example. But the benefit of using the Pegasus system is you could drive that along a road or on track at any point with no ground control and still be accurate to about 20-25 mil in global accuracy. If you put ground control in, obviously you can bring that down to 10-5 mil, depending on how much ground control. But the relative accuracy is always sort of less than 5 mil, again, depending on point spacing. Because that every time it does a rotation profiler, that is one relative measurement. So if you measure from curb to curb, that's always going to be less than 5 mil. So this is the difference between sort of like relative and absolute accuracy, I suppose. So you've got global accuracy of where it sits in the world. So that's 20 mils drive along, but the actual measurements within that data set from curb to curb is sub 5 millimeter.
Yeah, all the mobile mapping techniques, whether it's the trolley, whether it's the GPR data, whether it's the Pegasus data here, they all essentially work on a very similar methodology. You're getting a trace of a centre line, a trajectory, to which then all the other data is stitched. So everything is then relative from that point, and the only thing that positions it is where that trace is.
So, yeah, I mean, a benefit of this, for example, we did a lot of work down in Kent for level crossings, so there's been a lot of work and a lot of talk in the news about level crossings, but we managed to drive sort of 18 to 20 level crossings in a day, so that will tie in with the data from the track data. So we'll push a trolley at night, and then we can go out during the day with this and drive sort of the 200 meters either way. If they're thinking about building a bridge or something like that, we can go a kilometer either way just in a day. So it's just a case of once this is up and initialized, which takes about 15 minutes, we've got custom built mounts in the back of the van. So once it's up in the air, it is as, I mean, I'm going to downplay a survey here, but it's as easy as pressing stop and start in the back of the vehicle to record that data.
It is to record
So
it. It's the
it is
skills
that
and
simple,
approach.
yeah. So it's just a case of driving it. That's it, yeah. So it's a case of just driving where you need to. Any bridges you need, again, any over bridges, any under bridges, we can drive along, press stop and start, and we can do multiple in a day. So what we always say with this is it is more expensive than a traditional survey because of the value of the kit and the value of the data. But what we always say to people who are looking at this is give us a bit extra for what you may need, because you're paying a day rate anyway. We're out there. So if you only need a kilometre, if you think in the future you may need a kilometre extra at either end, so 3 kilometres, just tell us and we'll collect that data. We don't have to process it or anything, but at least it's in the server ready to go and process later on down the line. Same with any bridges, any level crossings. If you're unsure, just tell us to do it and give us a bit of a priority list. These are the ones that need to be done. If you've got time, do these ones, and then we can obviously collect that and store it, basically data-wise. So another benefit of using this system is we can also mount this on pretty much anything, to be honest. Like you've seen that there on our RV, we've mounted it on the back of our vehicle, but we can also mount it on a boat. So for asset management and scour surveys, that sort of thing for us, for rail surveys, for some reason that picture's not come up, has it?
Yeah, have you sort of a bit challenged with positioning in that itself?
No, to be honest, the IMU inside of the inertial measurement unit likes movement. So the more movement, especially on a boat where it's rocking and moving, it likes that a lot more than being on an RV where it's nice and smooth on track. So the more movement, the smoother it can get, because it knows there's movement going on. Again, it's just positioned with the GPS again. But we teamed up with Shoreline, so this is Usk Viaduct, just outside of Newport Station. So they wanted a bit of an inspection, which you can do with a drone. You can fly around and get a few images and things like that, but they wanted the whole thing modelling with the, at the time, I think the OLE was going in. So we were able to get the multi-beam for under the water there, to see the sky around the actual structure, but then also get all the point cloud data. So we did multiple passes, trying to get into various locations. The profile there, you can see it's a 45-degree angle. So we can move around and twist the scanner in different positions just to try and get into all that metalwork there. And we were able to model that to, well, you can see that's the model that we created for it at the end of it there. We do have occasional issues. We did this on the Thames for a lot of the bridges, and we went past the MI6 building. Didn't realise at the time they've got a lot of GPS blockers, and the data went mental. It just went everywhere.
Like 200 meters.
It was, the road just went one smooth and just went directly north into the air, obviously, because that's what we want to do. With any missiles, if it comes in, just fire them into the sky. So there are some limitations to that side of things as well.
You need to know who you know, bizarre.
Yeah, that's it. We had to get some contacts and say, can you turn it off for 5 minutes while we do this bit? So yeah, that's so again,
quite a lot of those for bridge scale.
we've done quite a lot, and again, like we mentioned about drones earlier, it's not, we can go into it, we don't really want to. So I did a lot of hydrographic surveying for 5 years, but to buy the boat and buy the kit, we don't need to do that with a trusted partner like Shoreline Surveys. So if we can use them to do the underwater while we do the above water, all simultaneous, so all the underwater surveys positioned with our system anyway, so it's all joined together. You can see the sort of data set you can get there from above and below for any asset management in the future.
Yes, one of the things that's really revolutionised a lot of things, the fact that you can get it all together now.
That's it, yeah. Join it all together, and normally we'll go into it a bit. Actually, I'm not going to spoil Polish. So another system which is very new, starting to go with SLAM systems. So this is now laser scanning, but from being able to wear it on your person now and do a lot of stations. So it was initially built for manufacturing, but we're starting to see benefits of using it. For example, in a lot of stations, that's definitely a massive benefit for it. But also using it in surveys on highways where there's probably a bit more theft, for example, being able to reduce that down by being able to just walk around, laser scan, get a 360 imagery, and you've got all that at once. Another benefit of being able to use this as well is you can host this data online. So you don't need the software or anything anymore to be able to use this point cloud data. You can use this, if you want to use it in your own software, you can do it off the online portal and export the point cloud and use it to whatever you want. But you can use a shared login to this now, and we can set you up on your own login and use that as a bit of a health and safety tool as well. So if you've got any sites that are being built, you can put points of interest in where fire exits are, where fire extinguishers are, that sort of thing. And if it's we've recently done it at Manchester Piccadilly for the relay rooms up there. So we've been walking around and we can instantly share that data. So with about 80 people straight away. So this isn't manually processed anymore. This is processed in the cloud. So this is where it's starting to move to the point cloud data. So SLAM, I'm going to trim myself up here of what that stands for: simultaneous location and mapping. That's it. So basically it stitches itself to itself. So as you're walking around, you're doing a lot of figure of eights, overlapping yourself a lot, going around like that. So it uses itself, features in itself to map itself. Yeah. But you can also tie it down to the control as well. So as to Snake Grid, for example, any grids, localized grids.
Yeah, it all depends on the accuracy required. If you need slightly lower accuracy, then it's good enough. You know, if you're talking kind of 10, 20 millish, it's fine. Yeah, you don't need the control to do it. It can just orientate itself for what you're doing. Yeah. But if you want it to the traditional accuracies of kind of like static laser scanning, terrestrial laser scanning, no problem, you can tie it down to control. Yeah. But it's just about speeding up that data collection process. I mean, to be honest, 5 times faster is probably underselling it a little bit.
It is. I mean, Cardiff Station, which is a great example here, we laser scanned that a few years ago with traditional static laser scanning. That took us a couple of weeks. Yeah, by getting all the nuts and crannies, there's a lot more rooms in Cardiff Central than you realise once you start going for it. So that took us about 2 weeks. If we had this system at the time, it'd probably taken us a day, 2 days to be able to map all of that. So it's just infinitely quicker.
Yeah. So it's actually useful.
Actually, yeah, that's it. I mean, you've got to be very careful going through doors. As you can see there, it's hitting it off the profile. I mean, someone did it on day one. Luckily, it wasn't no damage, but the first day we bought that did hit a Endosol. But I mean, yeah, again, it's just for ease of data, and if you wanting it for not necessarily survey grade accuracy, but you want it for asset management, you can walk around the station, just have a 3D model of it. Perfect bit of kit that. And if you want it for any health and safety walkarounds, virtual walkarounds, even like high level designs for early stage things, it's perfect for that side of things. But from that data as well, we can model things. So that I mentioned there, Cardiff Central at the bottom there, so you can see the point cloud data on the left, and then we can create that into a full BIM model. So that was used for all the upgrade works which have happened recently. Mott McDonald are quite good for it. They'll ask for it in Revit or Open Buildings. We'll give them the model, and then they'll almost put their design into the model to see how it fits and how it works, essentially. An example, quite a complicated one, but at the top right there, we laser scanned and modelled a Heineken factory, which was a nice job for the people over there. But you can see the level of detail you can model to with the scan data that we've got. So every pipe, every little element there. So it depends on what level of detail you want. We can model to that level of detail. I mean, you can go as simple as we just want walls and windows. That's it. But we can go right through to every bolt if you really needed that in that much detail as well. But again, depends on the deliverables you're looking at. So a bit about utilities tracing, which is what we mentioned before. So that top right image there is what we mentioned about Coventry, where you're talking about the mapping above and below ground. So if we just, so that's a bit of a fly through. So that's the above ground mobile mapping. It's a bit grainy on there, but you can see the level of detail underground of all the chambers that were modelled, all the services that were modelled underground. The problem with utility surveys is there's never going to be that much technology where we don't have to lift covers and trace them. I can't foresee anything being that advanced to be able to do the actual physical tracing and the accurate tracing. GPR's obviously come a long way. You mentioned before about drones and things like that. That will go ahead. But the actual accurate tracing things, I can't see a way of going around it. We have done culverts in the past, large culverts, using, instead of sending people down there for confined space and that sort of stuff, we have used Helios drones, which is like a 300 mil ball almost that you send in there, and that can model culverts. So we've done that quite a lot on Transpennine route upgrades around the likes of Huddersfield Station and things, where we can fly in, get the data we need, model it, and then fly back out again. The limitation on that is if you send it down, it has to be a clear line of sight for signal, for one, and there's only a 10-minute battery. And that drone is tens of thousands of pounds. So if it goes, yeah.
So if it goes around the corner, you've lost it. Basically.
You've lost it, and then you'll never see it again, basically. So, I mean, again, we were always looking at different ways of doing it. I don't know if you've seen a robotic dog that Trimble and like to play around with and things like that.
So I think German railways have started using them for things like checking wagons in the yard. You have to take them
out
of wagons because it could just wander around to its arc.
That's it. So we've even looked into them for doing some of these confined spaces jobs. But then when you actually go to the dealer and say, yeah, there's a few like bricks in the drainage and things like that, we go, yeah, don't send it and it'll trip over and you'll never get back out again. So it's like, well, all right. It's not as good as it says it is then. So again, just trying to test and see what the latest technology is. But yeah, unfortunately with utility surveying, there's never going to be that much of an advance in technology. CAT scanners, they are getting better, but there's never going to be a massive leap in the near future that I can see at the moment, to be honest.
It's still a work in progress.
It is, yeah, definitely. And if you want the best quality survey anyway, you need to do this investigation as much as you can anyway at this stage. Yeah, I mean, one area where we have advanced on is manhole cards. So you've seen manhole cards come in, and the way we used to do it was writing a bit of paper again, transcribe it in the office to AutoCAD and deliver it. But we do it on, we've created an app now ourselves on a tablet. So it tells you every stage, what's pipe diameter, what's sort of cover is it, take this photo, take this photo. So again, there's less transcription errors. It gives you the card, and then that's exported straight away. You can send that straight away in the template. So that's one area where we have saved time.
Because I know sorting out these kind of underground services is an absolute nightmare.
Yeah.
And, my limited experience of it.
Yeah, I mean, we've done it a lot recently where we're helping with like borehole clearance, for example, and we come along and they say, "No, we've got stat plans. It's fine. Don't need you." And it's like, you do not trust. We always get the stat plans anyway because it gives you a good idea of what's going on in the area, but it's never right. To be honest, it's very rarely right. And like I said, they're accurate to 5 to 10 meters sometimes. So if you've got a gas main, you don't want to be drilling through a gas main at all.
Cool.
That's it. I mean, there's a really good example in Birmingham City Centre where they found a service, they thought it was pipe. They started drilling away, and they burnt out, I think it was something like 8 drill pieces until they said something's not right here. And they found out it was the main pipeline for Birmingham Airport, for the main fuel line. So if they had gone in through that and caused a spark, apparently that would have caused them, can't remember, like 10 square kilometers, something of land just gone if they've gone through. And that was just because the stat plan said there was that there, that was over there, but in reality that was there. So it's those sort of things that we've just got to keep a good eye on, that sort of things.
Yeah, I think the beauty of this is you've actually created a record now, isn't it?
Yeah, that's it.
You can,
I mean, the best way to do it, which I'm not going to force out there because it'll put us out of business, but it would be to survey it in as you put it in. That is the easiest way of doing it. And we're working with Heathrow Airport quite closely at the moment and trying to convince them that you just need a surveyor on site. I mean, you don't even need it that accurate. If you've got someone with GPS plus or minus 20 mil, it's better than trying to trace it from the surface and try to do it that way.
Trench was day.
That's it. Yeah.
If you
start, we're working with them a lot at the moment to try and push that workflow through, just to give them a live record of what's there and what's not there.
Swiss railways have a big, well, I don't know where they've gone with it, but
yeah,
that's a multi-layer model, and they're constantly adding new layers and details as things progress.
Well, Norway and Denmark, they've got it down really, because obviously if you've got a contractor that you bring in to do some drilling or excavating or something like that, the onus is on the contractor to make sure that hit anything. Whereas in Norway and Denmark, the onus is on the provider of that service to make sure that their records are up to date.
Where it says
so yeah, it's flipping it around basically on their head, saying if you want to look after your assets, you make sure you've got an accurate record of where they are. So that's why they don't have. We've been asked to do a few surveys, utility surveys over there, because they don't have utility surveyors for that reason, because it's all up to date records basically. But it's going to be a bit of a turnaround to try and do that in the UK. I think. I don't think that would happen.
The challenge the Swiss are finding is it costs a lot of money to get it up to date. You know, I think they had something like 40 people, and that's all they were doing was workshop, correcting, I think, loading new information and all that kind of.
They are trying to do that in the UK at the moment, but it comes down to money again. Like if one client's paid for a utility survey, they're going to be happy to just send it to this national database. Maybe not. So it's
something they're trying to establish, though, isn't it?
Yeah, they are.
Yeah,
I think it's Neura, it's called.
I think because otherwise things just get surveyed like 10 times.
Yeah, that's it. Which it does. So a little bit on the environmental background. So we mentioned before Dawlish. We did all the survey work for Dawlish after it was wiped out a number of years ago. Now, probably 10 years ago, actually, wasn't it? It's 10-year anniversary. So just wanted to bring up Dawlish because it was a great example of bringing all of our services into almost one package for this job. We did a survey out to about 5 kilometers out to sea using the boat, just so hydrologists could work out how the waves will come in and hit the sea defense. What we also found was we used the GPR on top, so any pipes, any services, obviously when they're building, we did all that. We used the Pegasus on the back of a pickup quad bike, sorry. So again, another service, so we could drive the sort of like a few kilometers down the beach where the sea defences were, and we used the GPR system there. But yeah, what we found was that the sea defences used to be full of sand when it was built. So when the waves hit the wall, it would sort of absorb that impact. Over time, it was filled with concrete, which then the impact was straight on it, and it's starting to affect the buildings behind, and cracking was starting to appear behind, and all that sort of stuff. So we started finding that. And one thing I did discover while doing the night shift there was that the ballast is glued down there. So I tried to kick some ballast off a catch pit, and that went over my head because I didn't realise
It all washing out.
that was it at the time.
When the sea was overtopping, yeah.
But no one gave me any warning on that when I went on track. So that would be nice at the time. But it's just a great example of showing all of our services all in one, being able to do track surveys, the wall, the beach, and all the services around it as well.
Yeah, I mean, yeah, you top right there, you can see the Pegasus mobile mapping system attached to the back of the quad bikes. It's really function like versatile bit of kit. At the time, I get the names.
The stream up wasn't available, yeah, so it was all hand pushed up.
But now you could, in theory, just put that on the tow hitch and just tow behind you as well.
Yeah, on the back of the quad bike would have been a lot quicker. But then, so it just shows you again how quickly it's moving along as time goes on. And those two images at the bottom are data, not photographs. That's actual data we collected for the actual Polish seawall there.
So there's, to move on to a slightly different topic now, with all these different data sources coming in, you touched on it a little bit there, is they all need to link together somehow. And for the records going into the future, so that data can be used many times, they need to be on some kind of recognized coordinate system underneath it. Otherwise, that's easily relatable to other data sources. We say we've got mobile mapping data above and below ground. All the new construction works with machine control, all GNSS enabled now. Everything it needs to be relatable to the wider world. Projects aren't local anymore. And the key bit of information to that, which sometimes flies under the radar a little bit, is the coordinate systems for your projects. That really is one of the key bits that can define how well your project goes, whether it runs really smoothly or whether it runs into trouble later on in its life. And so we're just going to have a look at some different options, because sometimes it's not something which is widely spoken about, but we thought it might just be worth just touching on briefly. We've got loads of other information on this, so if there's more information you want on particular bits, we can look at it, or if there's any questions as we go along, because it can be a little bit of a abstract kind of concept sometimes, feel to just jump in and ask. Everyone in the room, I presume, is kind of fairly happy with OS National Grid. Really good for just general positioning around the UK, but it does contain distortions. What you measure in between two coordinates in the National Grid is not what you see out on the ground. This can lead to all sorts of problems with design and setting out and construction workflows, because whatever we got kind of PUA designers here, bits and pieces. Yeah, so whatever you guys design, whether it's your nice high-speed transition with a very particular geometry, if you design that in the office and your coordinate system doesn't represent what's on the ground, what will be built is not what you designed. And that can have various implications, potentially for safety, potentially reworks, cost, redesigns, and things like this. So if you're working in a coordinate system that has distortions in it and scale factors, you need to make adjustments between what you see in the office and what you have on the ground. And likewise, when we're doing the survey, we need to adjust what we measure so it sits in the right space in the office. That interface increases complexity and adds an awful lot of risk to your project. So there were several approaches in the past which have been taken to try and take that out. Instead of changing what we measure, the other approach is to say, okay, well, let's change the coordinate space. let's try and minimize the distortion in that coordinate system so it better reflects what is actually out on the ground. Trying to get closer to that one-to-one relationship. So what you draw is what we build. There's a few different approaches have been taken. Either completely local arbitrary grid systems, which were quite popular with construction sites and old before the advent of GNSS, really. You know, your old kind of 1000 type coordinate systems, absolutely fine, but not relatable to the real world. Zonal systems, HS1, if anyone's worked down on HS1, that had a zonal system. I forget exactly how many zones, but I think there was about 5 to 7 different zones where they minimized the scale distortion within those zones to better reflect the real world. Works really well if, you know, within the zone, but as soon as you start crossing over zone boundaries, you have to work. Your design has to be in 2 coordinate systems, it has to be set out in 2 different coordinate systems, and there's questions on site that boundary is not visible in the real world. So for people who's doing all the setting out and the construction work, those interfaces are a high risk area. Other approaches which can be taken, you can take a standard map projection, something say similar to like the underlying OS map projections, but you could tailor it and shift it so it's more centered on your sites or where you're actually working. That can work really, really well. It's slightly more complicated. Maybe you need a little bit of knowledge from your surveyors or from a geodetic consultant, maybe to help you set that up. But it does give you a really good corridor where you can work with and not worry about these corrections back and forth. It is, however, limited because your project needs certain characteristics for one of those standard projections to be able to be used. And it also can't cope with any kind of significant height changes, which is another cause of major distortion in the grids. If you think about kind of concentric circles going out and you're reducing that down to the same mapping plane, it's further up here around this circle between 2 high points than it is lower down. Actually, I've got some diagrams and bits and pieces if they're helpful. So we're talking there about certain characteristics, and this is kind of really where the next solution kind of came out of. They tried zonal systems with HS1. They were just coming in to introducing pendolinos on the west coast with ATG and maintaining that 3D track geometry. Yeah, that's where we're heading next. There is no standard projection you could use that will cover London to Glasgow. You just can't do it. You can't fit it on one grid. You know, likewise, you can't go if you wanted to follow like the M4 motorway from London to Carmarthen. Can't do it. So, Network Rail approached University College London, and we're now in. Well, at the time, Jonathan Iliff was the professor there. He came up with the solution that we're going to talk about next. He's since retired, and we're now working in partnership with UCL to develop snake grid services and offer them out. The image on the right there is the Core Value Lines project. A lot of height change, as well as width in the projection. That we may.
It's a lot of. Oh, sorry. It's a lot.
Is that aimed this way or?
Sorry, that was
it's
my
all
fault.
right, no. Yeah, so Jonathan came up with the concept of a snake grid. And now, has anyone worked with snake grids? Yeah. Had a lot of familiarity with them at all?
I think some of the challenges with keeping it accurate enough, yeah.
Yeah, so what a snake grid is, it's a winding projection. So it changes the parameters as you go along. So you give us a route and we will tailor that projection, and it twists and turns and follows the rough trend of where you want to go in plan and height to create you a low distortion corridor where the scale factor and the distortion in that grid is below survey accuracy. In effect, you can consider it to be 1-to-1. So if you draw that high-speed transition in the office with very particular geometry, when it gets set out, it will be set out exactly as you want it to be. There's no interface, there's no corrections as you move between the site and the office. It is completely seamless. What you see and measure in one is what you see and measure in the other. And it gives you several things across the project. Just tried to highlight a few of them there on the left. It's about quality control. There's no more questions around the grids. There's no more interfaces. There's no corrections. There's no changes between zones. It's a very straightforward process in moving between those two different worlds. So we've already touched on that relationship there and the seamless link between, as projects go on, it's not just, particularly with new projects, but also with existing assets. It's not just about the survey and do the work. There's a lot of maintenance and preserving life and extending that and having that data like you're talking about with utility information and the old survey data. We've got all this information sitting in silos and so much of it. But if they're all on their own little local grids or bespoke solutions here, there and everywhere, you can't easily relate all that together for your latest project or for the actual ongoing future of things. If it's all on the one coordinate system, say the Wales and Borders Core Valley Line Snake Grid, well, I think it's called something slightly different now in 22, but it was originally done in 2018. All that historical information can be brought together in one place, and it overlays the accuracy that the data was collected. This brings in lots of benefits in terms of saving time and money, reduces risk reduction to reduce setting out errors, any rework in design and things like this. And we're touching a little bit there about asset management and how all this is, because it's a known definable coordinate system, you can easily flip that into another coordinate system elsewhere and overlay data sources. I think the next slide touches on that slightly as well. Just a little bit from more of the office side about where you'll be able to access them, more bits and pieces. There's various plugins for MicroStation users, FME. This sits within the Autodesk environment as well, if you've got any Autodesk users. Particularly with this new, if you work with Snake Grid, you may have come across the NTV2 lights a little bit, but we don't need to go into that. But essentially that opens it up into any software. Things like ArcGIS, QGIS, MicroStation, all the grids are freely available in there. And that ability, because you're then within their geographic libraries, you can project data back and forth on the fly. So you can overlay all your data sources together and see how they all interact. And I think there's just a little bit there about what you just provide us the details of where you want the grid, where you want it to be covered, and we streamline your workflows, reduce risk, and give you confidence in your data moving back and forth. I'm sure probably many of you know they've pretty much most of the main lines in the UK are covered now with Snake Grids, but I think I was talking to Bogdan the other day, and it's almost projects over certain sizes. It's almost mandated that you have to be working on a Snake Grid now because of the benefits that it brings.
Yeah, there's been some bit of whinging recently about the cost of maintaining it all. So
the control,
keeping the grid up to date, and
once it's been realised on the ground.
Yeah.
So the grid itself, there's two different elements there. You've got the projection on one side, and that exists regardless, and that can just sit in the background. There's no cost or anything to that. Yeah, that's just like it's algorithms that move lat longs to easterns, northerns. Once you realise that grid on the ground, that then becomes like subject to observational errors. If you put it in with GPS, all those, it'll be as good as your GPS is. But if you then measure your track to that you then need to maintain that control if you want to be able to constantly revisit where that track position is. But the fundamental projection sits behind it. So there's a difference between kind of being able to just go and continually do new surveys, or constantly maintaining a reference frame on the ground, because it's like the OS maintaining trig pillars. That's in effect, once you put a PDM in the ground, that is what you're then having to do, is effectively maintain. There's quite a lot, kind of, we skimmed through probably what is can be a really in-depth, complicated topic. If there's any questions around that, we've got other bits of slides and we can go in and talk about a bit more about how they're generated and developed, if that's of interest, or bits and pieces, or yeah, we can leave it at that level as well, if and move on if people are happy.
I'm quite interested in this.
Oh yeah, so go on.
I was just saying, I'm quite interested in this. I'd quite like to hear more about it.
Yeah, I mean, if you've got any other questions or bits and pieces, we can, I'd be happy just for, if there's some way you can send those across, or we can chat about it at the end. And if not, if we run out of time, if you send the questions in, I'm sure they can be fed on to us and we can provide you with more information.
Lovely, thank you.
There's only a couple more slides, I promise. Monitoring has come along quite far in the last couple of years. That's monitoring for movement, temperature, noise, dust, everything. So traditionally that was always done with a person with a tilt station shooting targets similar to over and over again to look for movement. But we're now moving on to more boxes, tilt sensors, remote monitoring. So the benefit of this for larger projects is you can stick down the little boxes, very tiny boxes around about that sort of size. You can stick these on sleepers. You can stick them on posts in embankments to review monitoring. And these will also be sent to the cloud. So you can have these reading every minute, every 5 minutes, every 10 minutes, every hour, depending on what your requirements are. And depending on how long you read for, the batteries can last up to 10 years as well. So dropped up bits. For longer term projects, it's cheaper than sending someone out there constantly to do the readings. Especially if you think about in the summer where you've got critical temperature readings, especially on network rail, we can just put a little sensor on the web of the rail and that will constantly give you readings straight away. And we've also got little boxes that feed back to a gateway. So if one of those sensors does go down or the gateway goes down, that will still store the data. We can quickly put the batteries back in, keep it moving, and then all that data will be uploaded still again. So if one of them goes down, it can bunny hop that data between all these different sensors all the way on track. Same for any environmental monitoring as well. So if you've got an area where noise might be an issue or dust might be an issue, we can do that automated as well, and that will all feed through to the same gateway and give you all results. And these alerts as well are set by network rail standards or the project standards. And these you can be put on the list, so you get the alert instantly when it happens, rather than obviously waiting for someone else to give you those results. They'll happen instantaneously.
Those readings, the frequency of readings can be set by triggers as well. So once it starts detecting movement, the frequency of readings will increase. But like Mike was saying, you can, essentially, although they are kind of tilt sensors and bits and pieces, they are also just a means of communication. So you can attach virtually any other sensor or camera, anything you want to that, and they'll just feed the information back through the gateway.
So they're all triaxial movement as well. So they're detecting movement in all directions, but we've also got sub-millimeter readings. So even things like the air temperature can be shown on it. So between day and night, you'll see a movement curve. So we normally try and put them out for 2 weeks before this to try and smooth out those environmental factors straight away. And send that through. So we what's the next slide? It's just a quick video on showing you sort of like the different too far. It's not gonna work now, is it? We'll press it too quick. So we still do the traditional automated sort of ATS systems, which can constantly shoot. So a lot of them you've probably seen on HS2, but they're quite liable to being nicked at the moment. A lot have been nicked on HS2. I think 200 of them were nicked. Again, they're looking for movement walls, also tunnel convergence there. So they're almost like little distos, so they can show any fluctuations in the tunnel. So we've been doing that on the Camp Hill lines in Birmingham. because they've had quite a lot of cranes on top of this tunnel, and it was an old Victorian tunnel. Obviously, they didn't want anything collapsing, so we've had them in there for about a year now as they're doing work above it and around it. And yeah, in the embankments that look to move in. I mean, the most triggers we get from badgers digging them out, or people just picking them up and wondering what they are. That's a very common issue of people just picking them out and looking at them. So that is probably our biggest issue. But yeah, it's all about keeping people off site again and just doing things remotely as much as we can. And that's about it. So yeah, we cover, like we said, rail's probably our biggest. It was at 1.80% of our work, but we did diversify as CP7 sort of closed down and recessions and things, so we're more guarded, but we do work throughout all these sectors and yeah, a few of our accreditations there. But yes, thanks for listening, everybody. It was probably longer than we thought it was going to be honest. So hopefully there's a few good points in there.
Absolutely fascinating. So we've got any more questions? We've got any more online?
No.
Right, any questions from the room? So, yeah. I've been with silence.
I've got one regarding monitoring. Are you able to monitor inside the tunnel or any other underground structure? And if so, how do you get the signal out from underground to the cloud?
So we have gateways. We can have 2 gateways. So when we're doing a longer tunnel, so if you used sort of like Morley Tunnel on TRU, for example, quite a long tunnel, we'll have gateways at either end out in the open, so they've got signal.
Yeah.
These sensors that you have throughout the tunnel, say you've got them on sleepers every 3 meters, they will bunny hop the information between the sensors themselves until they get out of the tunnel. So as long as they're within sort of like a certain range, so if one of them went down, they can still bunny hop over to the next one and still carry that data through. So that's how that works, basically, just transferring the data through.
Questions? No? Right. So what a fascinating talk. As you said, it's come a long way, hasn't it?
Yeah.
And it's progressing all the time. And it's really useful for me, certainly, to catch up with where some of these things are going. And I think the power of being able to integrate all this stuff now is we're only just starting to, if I understand the full benefits of that, aren't we? So, and it's interesting to hear the government's thinking of setting up an agency to do it, but they'll probably use Windows 3.1. It won't work. But so thank you very much for coming along this evening. I bet you both got a fair way to get home tonight. Otherwise, you'd be welcome to join us for a pint if you wanted. So can I ask everyone to join me in the usual way to show their appreciation?
Thank you. Yeah.
Of other things, some bloke called Andy Franklin's doing the next meeting. So maintaining track geometry for 300 km/h operation on CTRL section 1. So I'm doing a bit of a retrospective on sort of where we were then, and perhaps some of the things about what's gone well with CTRL and what hasn't, in a broader perspective. And really looking back to the original concepts from the 70s. So that's next time. Right.
And it's at 5 o'clock start.
5 o'clock start.
Yeah.
Right. Okay. 5 o'clock.
Rather than 1:15, it's going to be 5. Because the reception staff downstairs leave at 5. So we've got that 15-minute gap where we have to send James down to pick up any latecomers.
Right.
Is that a permanent change? Yeah, I think it will be, yes. So it'll be 5 rather than 1:15. Good idea.
Yeah. Okay. So don't forget to sign out when you head out and leave your tags downstairs when we're done. Okay. And we're working during us at the Prince of Wales. So thank you very much again, Jeff.
Nothing very much for having us.
Thank you.
Thank you.
Thank you.
Cheers all. Thank you.